example 2 is more of the same, just involves some more complicated exponent rules from the past. So first of all, in A, look at the numbers that are present. We have a power with a base of 2 on this side. We have an 8 on this side. And we have a cube root of 2 on that side. So a couple of things, preliminaries. I hope you've seen your powers chart of 2. That 8 is 2 cubed. So if I want to have everything in the same base, I can change the 8 to 2 cubed. And the next thing I'm going to ask you to remember is how to change radicals to exponents. Do you remember that the square root of something, like the square root of x, is the same as x to the half? A cube root of x is x to the third. So this cube root of 2 is the same as 2 to the third. If you don't remember that, maybe you make a note up here. Maybe you do 3 of them. That we can change a radical to a fractional exponent every single time. Why is that important? Because in this question, we want to get both sides to be a single power with the same base. I'm close here, but I don't have a single power on the right-hand side. So now you're going to be asked, what was your rule for multiplying if the bases are the same? Go to a simpler one. What would you do if you had x squared times x to the 5? The answer would be x to the 7, right? Because I have 2 x's here and 5 x's there, all multiplied together. I have 7 x's all multiplied together. What's the rule for when you're multiplying and you have the same base? You add the exponents. The same rule applies even if the exponents are fractions. I'm going to have to add my exponents. And then you have to ask yourself, well, how do I add fractions? I need a common denominator. 3 is 9 over 3. 9 over 3 plus 1 over 3 will be 10 over 3. And now we have succeeded in getting the bases the same. So x would equal 10/3. So solving these equations is going to require you to remember all of your exponent rules from grade 9 and the radical stuff from grade 10 and grade 11. You can take your time while doing it. So we have 125 and 625 as the numbers. We look at our powers chart. Do we have a column where we can change those both to the same power? Yes. They're both powers of 5. So I'm going to take my time. Sometimes if you try to do too many exponent rules too quickly, you're going to run into problems. I'm first just going to change these to my powers of 5, bracket 2x plus 1 equals cube root of 5 to the 4. So I changed 125 to 5 cubed, and I changed 625 to 5 to the 4. A cube root, here we have a square root. Square root would have an exponent of a half. A cube root will have an exponent of 1/3. And now we just have to apply our power rules until we get a single power on both sides. So on the right-hand side, I'm going to multiply 4 times 1/3 will be 4/3. On the left-hand side, I'm going to multiply these ones first. 1/2 times 3 is 3/2, and I would still have to the 2x plus 1. And then multiply that. 3/2 times 2x would be 3x plus. So a lot of exponent rules from previous years just to get to this point where I can now look and say this exponent has to equal this exponent. So I can write, so 3x plus 3/2 has to equal 4/3. I have to use my exponent rules. Get a common denominator, so this will be 8/6 minus 9/6 will be negative 1/6. And divide both sides by 3, and we get negative 1/18. Not something that could probably be easy to see by guessing and checking. Again, take your time and really review what your exponent rules are, right? So far today, in these ones, we've reviewed 3 important exponents, well, more than 3, but if you're multiplying exponents with the same base, if you're multiplying powers with the same base, you add the exponents. If you have square roots, cube roots, fourth roots, those become fractional exponents. And if you have an exponent to an exponent, then you multiply. We also had in our first example the negative exponent rule. So our goal is to get to this step where we've circled the things in green. Our goal is to get both sides to be a single power with the same base. If they're a single power with the same base, then it's going to be just a matter of making the exponents equal to each other and solving from there. Okay, circle questions 9 and 10. And I'm actually going to give you 5 minutes right now to practice some of these.